This is an introduction to the Forest Manufacturing Model 480P horizontal blade bandsaw. To start with, from the name, obviously this is a bandsaw running a horizontal blade. The blade is oriented to cut in a horizontal plane. This is a traveling table machine, so I put a workpiece onto traveling table. In this case, I have a manual traverse. I push the table to make the cut. A little bit more about the saw. This is a high-speed machine, relatively speaking. We're running a blade speed of about 3,000 feet per minute. That's typical for what you would use to cut plastics, foam, insulation materials, graphite, pretty much anything other than steel. I do have customers using these machines or similar to cut aluminum, but that's a little bit of a special application. Please call us before, call us to discuss your special application. The saw itself. So on the opposite side over here, the P in the name 480P stands for pneumatic. We use an air cylinder to tension the blade. So I've got an air cylinder, back where you can't see it, I have a manual control valve and a pressure regulator valve. Setting the pressure regulator valve controls the pressure going into the air cylinder and therefore the force applied to the blade, setting the blade tension. Pneumatics have a few advantages. First off, it's very easy to accurately and repeatedly set your blade tension. Compare that with a screw over spring mechanism. This is a much better way to get there. This automatically compensates for any issues with changes in blade length. Either it's manufactured a quarter inch long, a quarter inch short, or if you're really working your saw and the blade starts getting hot, that blade will expand. The cylinder here will maintain the same force regardless of blade expansion contraction. So you get better control of your blade tension, leading to longer blade life and higher quality cuts. The pneumatic system also gives, what anecdotally I hear from the customers, it gives the blade a softer ride and they do get longer blade life using pneumatic system versus screw over spring. Also makes it much easier to change the blade out. When blades go dull or break and you change the blade out, on a screw over spring mechanism you have to faff about with detensioning, removing the blade. Here you've got a little lever here. I flip the lever, blade goes slack. Change the blade out, flip the lever back, I'm tight, and I know I'm at the correct blade tension. So that's the pneumatic side. On the drive side, this uses, in this case, a 3 horsepower brake motor controlled with a magnetic motor starter with overload. Standard motor on this machine is a 2 horsepower. This machine has been upgraded to a 5 horsepower. The customers, this belongs to somebody just getting ready to ship it. The customer for this application is cutting something that's relatively dense, absorbs a lot of energy. So we upgraded them to the 5 horsepower motor. All my machines ship with a brake motor, some way to rapidly stop the blade. The idea is, first off, if you do not have a brake motor, the operator presses the stop button, and if you don't have something to stop the blade, it'll just spin down. It can take quite a while, 15, 30 seconds for the blade to spin to a stop without a brake. Potentially what could happen here is the operator has hit the stop button. In his mind, the blade is stopped. He reaches in to grab the workpiece, touches the blade, which is still moving, and off comes his finger. We don't want that. What we do instead is we include a brake on all these machines. The brake is mounted to the back of the motor. It's wired in series with the motor, so anytime the motor has power, the brake releases. As soon as you take power away from the motor, the brake re-engages. It has springs. So the blade stops, next best thing to instant. I'll demonstrate in a moment. Controls. This machine has relatively basic controls for us. It has a magnetic motor starter over here where you can't see it, but it gives you magnetic contacts and a thermal overload. Basically a start-stop button controlling an electronic switch. We do offer more advanced controls for these machines. On the pneumatic side, we can do a electronically controlled solenoid valve. That lets me add lots of features. It allows me to include a blade breakage detector. It allows me to include a low air pressure switch. It allows me to interlock the tension controls to the start, so you can't start the saw if the blade is not properly tensioned, or if the blade is broken, or if you don't have correct air pressure. I can also include some basic control logic on the starter side. When we do that, we have a nice cabinet with a fuse disconnect and a box, all the things you expect. Table. So the standard model 480p has just a fixed table. The table didn't move, and you slide the workpiece across the table to make the cut. This machine has the upgrade. This has a traveling table with a manual traverse. So for my customers cutting really light material, where you can just slide the workpiece across the table, make the cut, great. The heavier, slower cutting or more delicate workpieces, it makes sense to add a traveling table. So on this one, I have what I call it a grocery cart handle, a nice little guard so the operator can make the cut. We also offer, as an additional upgrade, a variable speed powered traveling table. And we offer that in different versions. If you think you need that, please give us a call. We'll discuss your application and what the right saw for your job is. Another little quirk or feature of this machine, obviously the working portion of the blade is right here. On this machine, the return portion of the blade, the non-working portion of the blade, is under here, underneath the table. So the blade loops around and underneath the table. For a lot of my customers, this works. There's historical reasons for that I won't bother getting into, but as a practical matter, it makes for a less expensive saw, basically not as tall, less expensive, easier to work with. We do also make a version of this we call the model 480i. I stands for inverted, where we flip the machine over and the return portion is high. That's what you need if you're cutting something very tall. The limitation on this machine is you can only raise the working portion of the blade above the table until the return portion hits the underside of the table. On this machine, that means you can raise the blade about 10 inches above the table surface. On machines with a fixed table, those are skinnier because you don't have all the rails and wheels and such. On those machines with a fixed table, you can raise the blade 18 inches above the table surface. This obviously has the traveling table, so max is 10 inches. This machine has provision for dust collection. We have what we call a dust collection nozzle wrapping around the blade to the point where the blade exits the workpiece. That's the best place to capture the dust. And we have it hooked up to a dust collection system over there. Let's do a little quick test cut here. The material I have today is something a lot of my customers are cutting. I'll bring it in close for you here. This is a material known as cellular glass. Relatively dense, very hard. It is what the name would suggest. It's basically a sponge made of glass. It's very abrasive. If I handle that piece more than a half dozen times, I'm just going to wear the fingerprints right off my fingers. It cuts pretty easily, but it's very abrasive. It'll wear out a blade in a hurry. So normally my customers cutting this material will use a carbide tooth blade. They're much more expensive blades, but they last much, much longer. So it's a cost-effective option. So I'll go ahead and spin up the saw. Oh, one more feature, sorry. A lot of features on the machine. For adjusting the blade height. I'm going to do this first cut by eye, but I have on both sides of the saw ratcheting crank handles. So to raise or lower the blade, turn these. You can do it from either side. Flip the switch, and it goes down. And then over here, sorry, again where you can't see it, I have an electronic digital readout showing me the actual position of the blade. You can calibrate it two ways. You can calibrate it such that it reads from the table surface. So if it visual readout says 8 inches, your blade is 8 inches from the table surface. You can also have it do increments. For example, you might make a cut, zero the counter, move the blade down 1 inch, and know you're cutting a 1 inch thick piece. So, can you turn on the dust collection, please, Ching? Start the saw. Just that easy. Kill it. And that's how you can cut glass. Beautiful, smooth, straight, flat cut. So if you have any questions or would like to discuss a specific application for a horizontal saw or any of our other machines, please feel free to call or email us here at Forrest Manufacturing. I thank you for your time.